Hello friends, welcome back to my video series on analysis of determinate structures. So now in these videos I will be just quickly going through the conjugate beam method. I will be giving a quick introduction about the conjugate beam method in this video, and in my further videos we will solve the numerical examples on conjugate beam method in detail. Now the conjugate beam method is also one of the method to find the deflection in case of beams. It is almost, I can say, the next level of the moment area method. There are two theorems here, as we used to have the two theorems in case of moment area method. Here also we have two theorems. Now before going to the theorems, first let me explain you about this diagram. So this is one of the diagram wherein it has some loading, some general type of loading. It can be uniformly distributed load, it can be uniformly varying load, point load, or anything it might be. So this beam we usually call it as a real beam. Okay, the beam with the real loading and everything, we call it as a real beam. Now to this real beam we draw one more beam, something called as conjugate beam. Now what does that conjugate beam consist of is, it consists of the same span as that of the real beam with the same supports as that of the real beam. Sometimes the supports will change, we'll come back to that part later, and it contains load which is not equal to the real beam. Instead, it contains the load which is actually the M by EI diagram of the real beam. I will explain you once again. Now the conjugate beam has a loading which is equal to the M by EI diagram of the real beam. We'll see this thing further. You will understand it much better. Now at present we'll quickly go through what are the theorems which are there in the conjugate beam. The first theorem, the slope at any point on the real beam, please note this, the slope at any point on the real beam is numerically equal to the shear at the corresponding point on the conjugate beam. The slope, when you want to find the slope at any point on the real beam, to do that you need to find the shear at the corresponding point on the conjugate beam. That is the meaning of the first theorem. Now when you come to the second theorem, the displacement of a point on the real beam is numerically equal to the moment at the corresponding point on the conjugate beam. Now the meaning is, if you need to find what is the displacement or what is the deflection at a point on the real beam, you need to find what is the moment at that corresponding point on the conjugate beam. So these are the two theorems which will tell you how to find the slope and the displacement at a point on the beam. We'll elaborate this using one numerical example later part. Now when you come to the supports, there will be some changes in the supports at some specific types of supports. Now when in the real beam, if it is a pin connection, on the conjugate beam also it will be pin connection, and when it is a roller on the real beam, it will be roller on the conjugate beam. Now here, when it is fixed on the real beam, at that point you will have free end. Now when it is a free end on the conjugate beam, on the real beam, you will have fixed end on the conjugate beam. We'll explain that. Now these are the other types, like if you have an internal pin in the beam, you have hinge on the conjugate beam, and if you have internal roller on the real beam, you will hinge on the conjugate beam, and similarly this one. So you have to keep these things in mind and draw the conjugate beam and find out whatever is required. Now these are some of the examples wherein you will see how a real beam is there and what is its corresponding conjugate beam. Now if this is a real beam, its conjugate beam will look like this. You can see if it is a pin support, here also it is pin support, and if it is roller here, and this also becomes a roller here. Now when you see here, this is the cantilever beam having a fixity at this end. Now when you draw the conjugate beam, the fixed end becomes free and the free becomes fixed. So that is the very change what you have to see to it and proceed accordingly. Now here also the same thing, and here also it is the same thing, and here also it is the same thing. Means whatever real beam is there, the same thing you have to draw it as a conjugate beam, but there is some changes regarding the some types of supports, but the most important one is this one, which you have to remember a lot. So this is how this is a quick introduction to the conjugate beam. We'll try to elaborate the concept of conjugate beam and how to proceed and how to find slope and deflection on the real beam using conjugate beam method. We'll explain that using one simple numerical example in my next videos. Till then, thank you. Bye.